Let me introduce myself for the new people. Hello everybody, my name is Dr. Christian Seberino of Phil4. I provide math, physics, and computer programming classes as well as tutoring. My website is phil4.com. My email address is info@phil4.com. Right now I'm specifically going to focus on algebra. If you need more help, if you want tutoring regarding the math portion of the SAT, I also offer an SAT math prep class. See my website, phil4.com, for more information about that. Okay, so let's get started. Now, here's the deal. I'm going to be presenting a number of topics, algebra topics. Okay, I'm going to start by giving you some practice problems. I would like you to pause the video and try these exercises. Why am I doing this? The motivation is I don't want anybody to fool themselves into thinking that they understand a topic when they really don't. Okay? If you get my exercises all correct, then you're allowed to consider skipping that topic, that little piece of the video. If you don't get them correct, you're not allowed to fool yourself into thinking that you understand that topic well enough for the SAT. All right, see how that works? So I'll present problems and then I'll give you the solutions and then I'll discuss it. So please simplify these two expressions: 6x squared minus 4x plus 3x minus 2x squared, 5x squared y squared minus 2xy squared plus 3x squared y squared plus 5xy squared. All right, pause the video and try those now, please. Okay, here is the the solutions. 4x squared minus x, and then the second one is 8x squared y squared plus 3xy squared. Okay, now discussion. Only like terms can be combined. That's the principle I'm trying to get across here. You may have heard the adage, you can't add apples and oranges. Okay, you have to make sure that terms are of the same kind before you combine them. All right, and you've seen this idea before. For example, when you add and subtract fractions, you can only do that if the denominators are the same. Right? Also, radicals, same idea. You can't add root 2 to root 3 because they are not the same kind. Okay? So please keep that in mind. Make sure you understand that. All right, next topic. Would you please re-express the following without parentheses? I have there x times the binomial y plus z, and then I have negative k times the binomial k minus 4, and then I have u plus 4 times the binomial u minus 2. By the way, binomial means the sum or difference of terms. Usually or often you'll see those within parentheses. Okay, so please pause the video and try to re-express these now without parentheses. Okay, discussion and solutions. First, solutions. First one, xy plus xz. Second one, negative k squared plus 4k. And then the last one, after a couple of steps, u squared plus 2u minus 8. Okay, how did I get those answers? What I'm doing here is the process of distributing, also called expanding. And there, the first three bullets have some patterns, common patterns that you will see. All right, if you have a term in front of a binomial, you take that term and multiply it by each piece of the binomial. Okay, so the first one, AB plus or minus AC. If you have the product of binomials, you take each piece of the first binomial and multiply it by the second binomial. All right, when you do that, you will that itself, that new expression itself, you can distribute a second time. You can do more modifications. All right, when you do that, you will end up finally with 4 terms. Okay, that are some of them may be added, some of them may be subtracted. All right, depends on the original signs in the binomials. Okay, please commit that to memory. Please understand how to do these distributions. All right. Now, If you want to do the second and third patterns in one step, you could memorize a recipe called FOIL. Okay, we have a name for each of the four products in the answers. The answer for the answers for the second and third bullet. Okay, A times C, because those are the first terms of each of the binomials. That's called firsts, the first pair. That's what the F in FOIL stands for. Okay, A and D, those are the outer terms, the farthest apart. That's the O in FOIL. B and C, those are the closest together pieces. So that's the inners, that's the I in FOIL. And then B and D, those are the last terms of each binomial. So that's the L in FOIL. Okay, so if you want to remember FOIL, that might save you a few seconds. All right. Now, would you please express these without parentheses? All right, please pause the video and try that now, please. Okay, answers. First one, x squared plus 2xy plus y squared. Second one, 4x squared plus 12xz plus 9z squared. Last one, 9m squared minus 24mn plus 16n squared. Okay, discussion. Now, this is FOIL. We've already talked about FOIL. The reason that I gave you these additional exercises is I wanted to make sure you knew how to handle FOIL if both binomials were the same. All right. And you can see you'll always have this pattern. You can also memorize this if you wish. If you have x plus y, that binomial squared, you'll always get x squared plus 2xy plus y squared. And then if you have a difference, if you have x minus y, that binomial squared, it'll be x squared minus 2xy plus y squared. Okay? Now, would you please factor these three expressions? I have 5x minus 5y, then I have 4xy squared minus 10x squared y cubed, then I have ax plus bx plus ay plus by. All right, pause the video and try that now, please. All right, solutions. First one, 5 times the binomial x minus y. Second one, 2xy squared times the binomial 2 minus 5xy. The last one, the product of binomials, a plus b times the binomial x plus y. All right, discussion. What's going on there? Factoring, that's the topic here. Factoring is essentially like the opposite of distributing or the opposite of expanding. All right, you're trying to put the parentheses, you're trying to re-express the expression with parentheses. All right, how do you do that? You want to find what divides each of the terms evenly, each of the terms that are added or subtracted from each other. Okay, find the biggest term that you can that divides each term, and then that's what goes in the front of your parenthesis that you're building. Okay, you may need to factor more than once. You might do that and then find out, oh look, I can factor again. That's what happened in the last problem of the last slide. Okay, so make sure that you understand how that works and do lots of practice problems regarding factoring. Okay, would you please factor these two expressions? X squared minus 4x minus 12, and then 2x squared plus 10x minus 28. Pause the video and try that now, please. All right, here we go. Answers. First one, product of binomials, x minus 6 and binomial x plus 2. The second one, the binomial 2x minus 4 and the binomial x plus 7. Discussion. When you have a quadratic, you want to keep trying all the possibilities until you stumble upon the choice that works. All right. You will need to find a pair of integers that multiply to give the left coefficient, the number on the left. You'll have to find a pair of integers that multiply to give the right coefficient, the number on the right. Okay? You know that you've found the correct pairs when you expand it, when you do FOIL and you get the correct middle term. All right, that's the middle term is what's difficult to get. All right, so you try all combinations of all pairs until FOIL gives you that middle term. All right, after you do this enough and this becomes ingrained, you will see patterns. You will be able to do more of it in your head. You'll be able to zero in faster on pairs of integers that have the best possibility of getting that middle term. Okay?